This is a demo for the population sampling lab. I have my marked rocks and unmarked rocks that I'm going to go ahead and pull out here. So for the first one, we're going to be using this Peterson method, where you look at how many animals marked on your first visit, which is going to be 10. So I have the math here, 10. So I'll just take out 10 rocks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on each subsequent time that we're going to go ahead and recapture them, I'm also taking out 10, and I'll just put like a handful of these rocks in the cup. So for the hypothesis, just see, I mean, this is the size of the rocks. It's like maybe that full. How many rocks do you think it is? That's going to be the hypothesis. So in order for the Peterson method to be used, the N is we're figuring out how many rocks we think there are, just because populations can't move. So let's say we can't make all the deer freeze. So you capture 10 of them, you mark them, then you release them back into the wild, and then capture 10 more of them and use this math to figure out how many deer there actually are. So like I said, 10 is what I marked on the first visit. 10 is how many rocks we're going to take out on subsequent ones. And then we'll see how many marked each one. So here's the data table that you can go ahead and write. To start off, I'm going to go ahead and mix up all the rocks. And then with your eyes closed, take out 10 rocks randomly. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I was not looking. And let's see how many X's we have. I hope I have some. None. Okay, so that's the first one. There are follow-up questions too, which I'll answer, but marked rocks is 0. So we had 100 divided by the marked ones, which is K. But since it's 0, it's just 0. So that was the first trial. And we're just going to go ahead and do that 10 times. So on that trial, we had 1 marked rock. So number of marked rocks will go 100 divided by 1. So based on that math, it thinks that there's 100 rocks in the population, which may be a limitation in, like, when they say what are some limitations of this method, you already see one. The first method, or I should say the first trial that we did, it said that there was 0, even though obviously we captured 10. And then in the second trial they had 100, but there's not 100 rocks here. So we'll keep going. Oh my gosh. 2, 3, 4, 5. This time we had 1, 2, 3 marked rocks. Doing the calculator, 100 divided by 3 is going to be 33.3. Mix them up again. They're moving, they're moving, they're moving. 10 more. 3, 4, 5, 10. And we have 1 rock. So at this point I have all of the data. I'm going to go ahead and add all of these and divide it by 10 just to find the average total. So we'll go 100 plus 33 plus 100 plus 50 so 566 divided by 1, 2, 3, 4, 5, 6, 7, 8. is going to be 70.8 rocks, and then we'll go actual. And I'm just counting how many actual rocks there are, so 1, 2, 3, 4, 5, 6, 7, 8. 63, 64, 65, 66, 67, 68. So actually, we had 68 rocks. That is very close. We were 2 off by this method. So that is the mark and recapture method. Here is the data for you to answer all the follow-up questions.